Chapter 3: Trauma and Chronic Activation of the Cell. Danger Response. Introduction: The long-term impact of trauma. When a traumatic experience strikes, the body's immediate response is to survive the danger. But for many people, the effects of trauma don't end when the event is over. Instead, trauma leaves a lasting imprint on the body's cellular functions. One of the most critical examples of this is the chronic activation of the cell danger response, CDR, a cellular mechanism designed to protect the body from perceived threats. In this chapter, we will explore how the prolonged activation of the CDR leads to persistent physical, emotional, and cognitive symptoms. By understanding how trauma affects the body at a cellular level, we can begin to grasp why trauma is such a pervasive condition and how it contributes to chronic illnesses. Understanding the cell danger response, CDR. The cell danger response, CDR, is a universal defense mechanism that activates whenever the body detects a threat, whether it be physical injury, infection, toxins, or psychological trauma. When this happens, the cells enter defense mode, halting their usual functions such as growth, repair, and metabolism in order to focus on survival. The mitochondria, which are responsible for energy production in cells, shift from producing energy to conserving it, which leads to significant physiological changes. This temporary shift is designed to protect the body from immediate harm. In a healthy system, once the threat is neutralized, cells return to their normal state, resuming regular functions. However, in people with trauma, the CDR can become chronically activated, meaning the cells remain in defense mode long after the original danger has passed. This ongoing state of cellular distress contributes to many of the physical symptoms associated with PTSD, such as chronic fatigue, inflammation, and cognitive dysfunction. Simplifying the CDR. To expand further on this topic, think of the CDR as the body's emergency mode. When a threat like trauma, injury, or even a toxin appears, your cells temporarily stop what they usually do, like producing energy or repairing tissue, and they focus instead entirely on survival. This change is meant to protect you in the short term, but if the emergency mode stays on for too long, it can lead to long-term problems like chronic fatigue or inflammation. Imagine a superhero constantly staying in battle mode, even when the threat is gone. That's what happens when the CDR is stuck in on mode. This can contribute to many of the physical and emotional symptoms seen in trauma survivors. History of the cell danger response, CDR. Dr. Robert K. Naviaux, a physician-scientist specializing in mitochondrial medicine and metabolic psychiatry, developed the cell danger response CDR theory. Dr. Naviaux first introduced the concept in his 2014 paper, Metabolic Features of the Cell Danger Response, which highlighted how the CDR is an evolutionary mechanism designed to protect the body from threats such as trauma, infection, and toxins. His work has been pivotal in demonstrating how the chronic activation of the CDR can contribute to a wide range of chronic illnesses, including chronic fatigue syndrome, CFS, autoimmune disorders, and neurodegenerative diseases. Naviaux's research has transformed the way we understand the role of mitochondria, organelles within our cells, not just in energy production but as central players in the body's defense and healing processes. How trauma disrupts cellular function. When trauma activates the CDR, it interrupts the normal functioning of the body's cells, particularly their ability to produce and use energy. This is because the mitochondria, the powerhouse of the cell, switch from energy production to a protective state, conserving resources to deal with the perceived threat. While the cell danger response, CDR, is a critical mechanism that places the body in a state of defense during trauma, it must eventually be resolved for healing to occur. This resolution is achieved through salutogenesis signaling, promoting cellular healing and restoring normal function. In later chapters, we will explore how various therapies can stimulate salutogenesis to support the body's natural healing pathways. This survival response can be beneficial in the short term, However, prolonged activation of the CDR results in metabolic imbalance, which manifests as chronic physical and cognitive symptoms. Here's how the CDR affects critical processes in the body. Energy production. Mitochondria slow down energy production to conserve resources, leading to chronic fatigue and low energy levels in individuals with trauma. Inflammation. Trauma triggers an inflammatory response in the body, which is helpful for healing in the short term. However, when inflammation becomes chronic, it leads to various health issues, such as autoimmune disorders, digestive problems, and pain. Cell communication. In CDR mode, cells cease their normal communication functions, which affects the functioning of tissues and organs. This disruption in cell signaling can lead to cognitive difficulties, brain fog, and memory problems, all common symptoms of trauma. CDR and the brain, a neurobiological perspective. The effects of the CDR extend beyond physical health. They impact brain function as well. Trauma significantly alters the brain's structure and connectivity, affecting how an individual processes information, responds to stress, and regulates emotions. Key brain areas affected by trauma include amygdala. Known as the brain's fear center, the amygdala becomes overactive in response to trauma, causing individuals to remain in a hypervigilant state. This hyperactivity keeps the body and mind in a state of high alert, which is central to maintaining chronic CDR activation. Hippocampus. The hippocampus, responsible for processing memories, often shrinks in individuals with trauma. This makes it harder to distinguish between past trauma and present safety, leading to flashbacks and intrusive thoughts. The hippocampus is susceptible to cellular stress, making trauma survivors prone to memory difficulties. Prefrontal cortex. The prefrontal cortex helps regulate emotions and make rational decisions. Trauma reduces activity in this part of the brain, contributing to emotional dysregulation, impulsive behavior, and trouble concentrating. How the CDR becomes chronically activated. The CDR is meant to be a temporary response. However, in individuals with trauma, several factors can cause it to remain chronically activated. Unresolved trauma. When trauma is not fully processed, whether through therapy or other means, the body continues to perceive it as an ongoing threat. This keeps the CDR active, trapping the individual in a prolonged state of defense. Repeated exposure to stress. Individuals who experience repeated trauma or live in stressful environments are more likely to experience chronic CDR activation. Constant exposure to stressors keeps the body from ever fully returning to a state of rest and repair. Implicit trauma memories. Trauma is often stored in implicit memories, which reside deep in the brain and body and can be triggered without conscious awareness. These implicit memories reactivate the CDR even when there is no immediate danger. Chronic CDR activation and its physical symptoms. The chronic activation of the CDR has widespread consequences for the body and brain, contributing to the long-term physical symptoms commonly seen in PTSD. Chronic fatigue. The body's inability to produce sufficient energy leads to persistent exhaustion, even with adequate rest. Inflammation. Chronic inflammation caused by prolonged cellular stress can result in physical pain, autoimmune disorders, and gastrointestinal issues. Cognitive dysfunction. The brain's normal functioning is disrupted by the CDR, leading to issues such as brain fog, memory loss, and concentration difficulties. The role of the vagus nerve and polyvagal theory. The vagus nerve plays a critical role in regulating the body's response to stress, mainly through the polyvagal theory, developed by Dr. Stephen Porges. The vagus nerve is the longest cranial nerve, connecting the brain to the heart, lungs, and digestive system. It helps regulate the parasympathetic nervous system, which is responsible for rest and relaxation. In individuals with trauma, the vagal tone is often reduced, meaning the body struggles to switch from the fight-or-flight response back to a state of calm. This keeps the CDR active and contributes to the chronic symptoms of trauma. Strengthening the vagus nerve through therapeutic techniques such as breathwork, mindfulness, and somatic therapy can help reduce chronic CDR activation and restore nervous system balance. The connection between trauma and chronic illness. Research shows that individuals who have experienced trauma are more likely to develop long-term health conditions, many of which are linked to chronic inflammation, immune dysfunction, and metabolic imbalances caused by the CDR. Some common chronic conditions associated with trauma include chronic fatigue syndrome, CFS. CFS, which shares many characteristics with the chronic activation of the CDR, is frequently diagnosed in trauma survivors who experience profound, unexplained fatigue. Fibromyalgia, a chronic pain condition characterized by widespread pain and tenderness. Fibromyalgia is thought to result from dysregulated pain processing, which can occur when the CDR remains activated. Autoimmune disorders. Conditions like lupus and rheumatoid arthritis are more common in individuals with PTSD, as the immune system can become overactive and attack healthy tissues when the CDR is chronically engaged. Gastrointestinal issues. The gut-brain connection is disrupted in trauma survivors, leading to conditions like irritable bowel syndrome, IBS, and other digestive disorders. Key takeaways. Chronic CDR activation. The chronic activation of the CDR is a significant contributor to the long-term physical and emotional symptoms of trauma. Salugenesis signaling. Resolving the CDR and shifting the body from defense to repair is achieved through salugenesis signaling, which restores normal cellular functions and supports healing. Holistic therapies such as somatic work, breath work, and vagus nerve activation are essential for stimulating salugenesis and facilitating cellular recovery. Impact on physical health. A chronically activated CDR leads to energy deficits, inflammation, immune dysfunction, and cognitive impairment, contributing to conditions such as chronic fatigue syndrome and fibromyalgia. Brain involvement. The amygdala, hippocampus, and prefrontal cortex are affected by the CDR, leading to emotional dysregulation, memory problems, and hypervigilance. Role of the vagus nerve. Strengthening vagal tone through somatic therapies can help reduce chronic CDR activation and promote healing. Next steps. If you are dealing with trauma-related symptoms that could be linked to chronic CDR activation, here are some steps to begin the healing process. Focus on restoring mitochondrial function. Mitochondria play a critical role in the CDR. Look for therapies that promote mitochondrial health, such as frequency-specific microcurrent, FSM, photobiomodulation, or supplements that target cellular energy production. Explore therapies that reduce inflammation. Chronic inflammation is a hallmark of prolonged CDR activation. Consider therapies such as hyperbaric oxygen therapy, HBOT, herbal anti-inflammatories, and anti-inflammatory diets to reduce inflammation and support cellular repair. Incorporate mind-body practices. Therapies like somatic experiencing, eye movement desensitization and reprocessing, EMDR, or mindfulness-based stress reduction, MBSR, help to resolve trauma by calming the nervous system and supporting the body's transition from defense to healing. Monitor progress with tools like HRV, heart rate variability. HRV monitoring can provide insights into your autonomic nervous system's balance, showing how well your body is recovering from chronic stress and trauma. Work with a trauma-informed therapist. Partner with a therapist experienced in addressing the physical and emotional effects of trauma, who can help guide you through therapies that target your mind and body for complete healing. References. Afari, N., and Buchwald, D., 2003. Chronic Fatigue Syndrome, a Review. American Journal of Psychiatry, 160 to 221 to 236. https gocdoi.org 10.176/API/AJP/160.2.221. Cloud DJ, 2014. Fibromyalgia, a Clinical Review. JAMA 311-15-1547-1555. https DUI.org 10.001/JAMA.2014.3266. Navio, R.K. 2014. Metabolic features of the cell danger response. Mitochondrion 16.7-17. https://dui.org 10.1016/jmito.2013.8.06. Porges, S.W. 2011. The Polyvagal Theory, Neurophysiological Foundations of Emotions, Attachment, Communication, and Self-Regulation. W. W. Norton and Company. Siegel, D.J. 2012. The Developing Mind. How Relationships and the Brain Interact to Shape Who We Are. Guilford Press. Vander Kolk, B.A., 2015. The Body Keeps the Score. Brain, Mind, and Body in the Healing of Trauma. Penguin Books.